Okay, so let's take a look. Problem solving with quadratics. Okay, so there's quite a bit, as you can see, that we're going to tackle in this question. I didn't actually write the question down, but essentially the idea of this question is they've given us a model for the trajectory of a rocket. Okay, h is height in meters. Okay, and t is time in seconds. So those two pieces are important for us. The very first question they ask us is height the rocket is launched at. Okay. This form is the standard form. And usually when you have a question like this, you're probably going to have to reformat or change the form of the quadratic one, if not two times to answer the litany of questions it has here. So what we really want to keep in mind is what each form does, how it helps us. So I'm going to do a quick little over here. Our standard form, which is normally written as y is equal to ax squared plus bx plus c. Okay. In terms of a graph, what's helpful is c is the y-intercept. Okay. Our factored form, which is written as y is equal to a times x minus r, x minus s, or I think you guys sometimes have different letters. Do you remember what the letters you guys do?
S and T.
S and T, okay, a little farther down the alphabet. The S and T help us find roots, or x-intercepts. Okay, and then we have our vertex form, which is written as y is equal to a, still that a is there, x minus h squared plus k. So a, h, and k. And what's helpful about this is the h value and the k value are the values of the vertex. So the vertex is the h and the k, which are also known as like a max or minimum height. Okay, so we want to keep those in mind because then that's going to help us decide if we're in a form, what form we want to move to answer the next question. So let's go back to the original question. Height the rocket is launched. Okay, I'm actually going to start with a sketch, and if you look a little farther down, the question doesn't ask us to sketch until part C, but it's probably going to make sense to start an original sketch earlier than that, and then maybe modify as we go along. So I'm going to rewrite it there. What was it? Negative 5, 40, and 100? Okay. So we have negative 5 t squared, negative 5, 40t, and 100, I believe, were the numeric values. Yeah, positive 40. Okay. Because this a value in our standard form, I know standard's a little off the window, let's bring it back. There we go. This is our a value. Because it is negative, we know we have some parabola that faces downwards. Okay, so we can start with there. Now it's probably translated left or right from here, I'm not entirely sure. The 40 isn't that helpful at this point, but the 100 is very helpful because we're in that standard form. This is the y-intercept, which we had stated before. So the y-intercept, we're going to try to plot it. Let's say that is 100. I'm going to redraw our downward facing parabola here. And we're going to get something that goes like this. And maybe it goes up from there, maybe it goes down. Now, technically, we could go back this way too. But I am going to keep in mind, if that was my y and this is my x, they've replaced the y and the x. They're using different variables. In fact, this was actually not a y, but it was an h. So instead of y, it used h, and h was representing height. So how high up does the rocket reach, and then on our x-axis it was representing time. Okay, and it was time in seconds, in fact. Now, what's neat about a problem like this is if we have time on the x-axis, this value is 0. So this is when the event starts, whatever event we're talking about. To go backwards would to be go backwards in time. Yeah. Now, it is possible they ask us a question about if it were to fall at the same rate previous to when it was launched, where could it possibly be? They might be able to word a question like that. But in a practical sense, really this parabola starts here at 0 because our events start at 0. So what does that mean? Well, a launching spot would be where it originally starts. So where it originally starts is actually the y-intercept, okay? So graphically, we can point that out really quickly. But what if I didn't see it graphically? What if I still had the equation and I said, oh, I got to figure out where it's launched from? Well, when something is launched, we're essentially at time is equal to 0, okay? So if I take that original equation again, and we substitute 0 in for t, we get h at -5 times 0 squared plus 40 times 0 plus 100. These all disappear because of their zeros, and you get a height of 100. So both algebraically and graphically, we're able to show that the solution to part A is 100 in this case. So we'll go and put that in. Height rocket launched from is at 100 meters. Or maybe we'll do it in different colors so it's a little more distinct. Okay. How long until the rocket passes the window at 135 meters? Okay, so let's go back here. 135. Well, we kind of have to guess here. Maybe this is 135? It's possible 135 is up here and the rocket never reaches that. So we got to figure this out. Now, graphically, we can't do that yet because we haven't gone about the graphing process. But algebraically, we can start to find this. And let's scroll down a little. We have room. Oh, yeah, I got room over here. We're going to say we're looking for a height of 135 meters. Now, our equation algebraically says h is equal to the standard form. And what we're going to do is we want to solve for t when h is 135. We can do that. One of the standard ways to solve any quadratic is to always eventually set it equal to 0. Now, I currently have two variables, but this is equation in itself. H is equal to 135. So we're going to replace the value of h with 135. And then the goal from here is to set this quadratic equal to 0. That way we can isolate for t. So 135 is going to come over, and we have 0 is equal to 5t squared plus 40t plus 100 minus 135, which will give us 0 is equal to 5t squared plus 40t minus 35. Okay, so now we have a slightly different quadratic to solve for. Now we could go through this process of trying to find all the graphical points, but we're going to do this algebraically. And just to try to make sense of our solution, there are three potential answers. There's a potential answer here where it crosses it twice, on the way up and the way down. There's a possible answer where the vertex is exactly at that window. And then there's a possible answer, that the parabola doesn't actually reach that height. It never reaches that. So we know that these are all potential answers here. Now what I have to suss out is, have you guys done quadratic formula? No. Have you done factoring? Yes. Okay, so we're going to do factoring. We could do something called completing the square. Does that sound familiar? Nope. Oh, then we're going to do factoring. It is. Okay. All of the methods I mentioned you'll eventually learn, and they're all potential answers for this, but we'll stick to the factoring one. So for factoring, we're going to use that crisscross method. So I'm going to look for the factors of the first term, and luckily that's a prime number, so that works out nicely. And then the second term here, we have 35 and 1, and we have 5 and 7. And then our products need to add up to positive 40. Okay. Quickly looking at this, where are we going to get 40? Oh, I see one. Oh, but one of these needs to be negative. 35 minus 5. 5 and 35. But one of these has to be negative. Okay, this is what we're going to try to do. I'm going to try to push this across. Let's see. 5 times 35 is going to give us 175, I think. Is that right? Yeah. It's going to be a really large number, and 1 times 1 is going to be 1. Clearly not going to add to 40. So we can go across instead. We have 35 and 5. That works. But the only thing is this is a negative 35. One of these would have to be negative, in which case this doesn't pan out. We don't get a value here. If 35 was negative, then it'd be negative 30, and if 5 was negative, it'd be positive 30. So neither of those work. Which takes me, I'm starting to think that this solution is going to be a little more complex to come across. Let's write that down. Okay, so in other words, this version doesn't work. There's another version. Here we go, 5 times 5 and 1 times 7. 25 and 7, that gives us 32. Not quite what we're looking for. And then 5 times 7 is 35. 1 times 5 is 5. That works. But again, one of these has to be negative. So I'm at a impasse here. I wanted you completing the square. Let me quickly... Or, maybe that's what this is telling us. I may not be able to factoring it, and there are other ways to factor something. It's possible we get a really unique answer here. Not unique, sorry. A non-integer answer, I should say. But I'm going to think back to what I said. There are the possibility of 2 points where it hits, right at the 1 point, or not hitting at all. I'm assuming you guys haven't heard of discriminants yet. No. Okay, so what we're going to do instead is I'm going to kind of write this one off. I'm going to put it on pause. I'm going to say stop, and I'm going to come back to it. And the reason I'm going to come back to it is because I recall from reading, one of the questions is going to ask me this. Max height and time. That's going to let us know if we pass this 135. And in which case, if we do, it gives me some more information about how to solve this piece. Because I'm struggling to factoring. And maybe I'm just not seeing it at a first glance. But I'm going to make sure that there is an answer to this before I continue to go. So we put this one on pause, okay? So we're going to say pause, and we'll come back to it. What do they use, like the 2 lines for pause? There we go. A sketch. Well, we have a rough sketch. We have a rough sketch, but we don't have many important points. So we're going to keep our sketch here. There's one. Oh, there it is. When does it hit the ground? Okay. When it hits the ground is very similar to what we're doing. Okay, but in the very first question, they wanted to know when it got to 135. Well, when something hits the ground, what's the height?
0.
Yeah, so h at 0. So we're going to do the exact same process, except that when we plug in a value for h, that's 40t plus 100, we're going to set it equal to 0. And since it's already set equal to 0, we're going to go through the factoring process with these values, okay? Same stuff, crisscross method. We have a prime number, and then 100's got lots of options. So this one could take a while. 5 is 20, 6, 7, 8, 9, and then 10 is 10. Okay, crisscross method. We need to get to 40. I'm going to knock this one out right off the bat. That one's just not going to work. 500 or 105, definitely not going to work. 250 or 10. Oh, this one looks like this could be it. It's positive. Oh, maybe not. Yeah, we get 10 and 50, but nothing's negative, even though there's a difference of 40, so it doesn't quite work. And, well, if we go 50 and 10, same idea. 50 and 10 doesn't quite work because there's no subtraction. Because this last term is positive, oh my gosh, this is a negative term. And you know what that tells me back here? This was a negative term. I found our error. We found our error here. Because this is negative, so now we're going back to our crisscross method, we probably could have got away with our very first version of this. Let's use the version we're currently on. If 5 is negative and the 1 is negative, then this becomes positive. And then 5 times 7 is 35. That checks out. So that was my error. I had a little transposition error. I forgot to bring down this negative. And that really changed everything for us. So let's go back to solving this. I can come revisit, which is a good math strategy sometimes. Go, you know, I'm not sure here, but I have the ability to get more information and then come back to this. So we found our little error. So we go back to this. 0 is equal to, because we use crisscross, -1 and -5. So -1t. And in the second bracket, we're going to have 5t. And then -5 is multiplied by -1, so they have to go in opposite brackets, and then +7. Okay, this helps us to do some more information. So I've jumped back from this question because we've discovered our error, and then we're going to go back forward again. The reason we set it equal to 0 is so that we could split. 0 is equal to -t plus 7. That's one potential answer. 0 is equal to 5t minus 5. In this version here, we get t, so I'm going to bring t over, is equal to +7. And in this one here, we get 5 is equal to 5t, in which case t is equal to 1. We divide both of those by 5. So it turns out that it does hit it. In fact, it hits it twice. So we're going to go revise our little graph here. Like we said, there's an option where it hits it twice. Well, in this option, at 1 second, it hits it. And then again, it comes back down at 7 seconds. So we've just updated our sketch here. Now, the question asks when it first, how long until the rocket passes a window? Okay, so to answer a question like this, we'd say it takes 1 second to pass that window. We'll say it's the quickest term. But just be aware there are potential for 2 answers. Let's go back to the ground now. We were back solving on the ground. This one technically I think worked. Yeah, because we had a negative, we say we had a -5 here. 5 times -2 gives, or sorry, -5 times 2 gives us -10. 1 times 50 gives us 50. That works out. So this version could technically work. So could the 10s, just like you said. You could have worked it with the 10s. 0 is equal to, we set up our 2 brackets for factoring. We put -5t in one of them and +t in the other, or just t. And then we just got to make sure whatever we multiplied by, we put them in opposites. So -5 was times 2, so we put +2 over here. And -1 was times +50, so we put +50 here. Because it's set equal to 0, this is when we split our equation. We get 2 different answers. 0 is equal to -5t plus 50. 0 is equal to t plus 2. Okay, we do some isolating. We bring 50 over, or actually I'm going to bring the -5t over. So we get +5t. Oops. +5t is equal to 50. We divide both by 5. T is at 10 seconds. And then the other option, -2. So let's make sense of this. We were solving for when the rocket hits the ground. Rocket hits the ground here at 10 seconds, and then it also hits the ground at -2 seconds. But recall, we can't go back in time. So for all our intents and purposes, this is it. At 10 seconds is when this rocket hits the ground, because that is when it's gone up and then finally come back down. So it's good. We're able to revise our questions. How long till it hits this one? We're no longer on pause. It's 1 second. And then you can make a note again at 7 seconds. We've updated our sketch. When does it hit the ground? At 10 seconds, not -2 seconds. That doesn't make much sense. And finally, max height and time. Max height and time, because we have our roots here, we can now find the axis of symmetry. The axis of symmetry is equal to first root plus the second root divided by 2. Okay?
I believe it's 4.
In this one, yeah, you're right. It's going to be 10 minus 2 over 2, which is 8, divided by 2, which is 4. So again, we update our sketch.
It's the max height at 4 seconds.
There we go. So it hits its max height at 4 seconds. And then the question becomes, what's that max height? Well, we just take the equation and we plug it back in. Where do I have room here? Here we go. I got some room on the side. Let's see. Whoops. Yeah, we're going to set t to 4. So we're looking when t is equal to 4. And we have our original question. H is equal to -5. That's what I kept forgetting. Plus 40t plus 100. Well, h, our height, is going to be equal to -5 times 4 squared plus 40 times 4 plus 100. In this case, we get -5 times 16 plus 160 plus 100. What's that going to be? Negative, we get 3, 5, 80. -80 plus 260. It's going to give us 180, I believe, will be our height. Might want to double check that. But I believe our height here, we go update our sketch. At 4 seconds, this rocket hits 180 meters in the air. So this is a little zoom out. A heck of a lot of work we just did there. We take more of a bird's eye view. There's 1, 2, 3, 4, 5 different questions, quite a bit. But just by factoring, we were able to solve all of this, right? And the key piece is when it got to 135, just being aware that setting a quadratic equal to 0 allows you to factor and then find different roots. That's an important process in this, okay?